Great.
Hello. Full
Nice.
screen.
Everyone can see that?
Yes.
Okay. All right, so I thought we were going to get a few more folks like Ian Shu from Apple, I think, who wanted to join, but I guess we'll get started and see if people come in a bit late.
I'm going to try to ping him.
Okay. So there's been a number of folks who've been working on performance-related stuff recently. Ben H and I were working on some performance improvements to the process. Ian Shu and Dimitri and Ilya, I think, were all interested in making master failover faster. So we wanted to just have a meeting, maybe do these on a recurring basis, just to discuss kind of all things performance. That includes things like, okay, how scalable can we make Mesos? What are the latency properties of our API? What's the throughput? How efficient are our libraries? How do we do benchmarking, and can we automate benchmarks, and so on. So today, I think what we wanted to do was just, do intros, which we just kind of did, and then talk about some of the work that's happening right now, and then hear a little bit from people about what they think the performance-related pain points are today, and where we might want to focus our efforts going forward. And then I put in something to kind of fill out like a planning table, just to figure out, who's going to be able to work on what things and who can maybe shepherd those things. And then I think James Peach, who I guess hasn't joined yet, he added some items here, one of them being the metric sampling, which there was some discussions about maybe a month or so ago. And then I guess he added benchmarking and build performance as well.
I see him on the list, so he should be here. I think he's muted.
James.
Oh, he is. Okay.
Hi. I joined a couple minutes ago.
Oh, okay. Oh, yeah. Okay. I see him now too. All right. So how does that sound, everyone?
Beautiful.
Agenda. Okay.
Sounds good.
I just need to grab power 1 second.
Hey Ben, do you want to in the chat in the Zoom? Do you want to share the link to the doc so people can follow along from their computers if they'd like? I think I might be talking to empty space. Oh, there he is. Hey Ben. Hey Ben.
Sorry.
That's your fine. Can you also in the chat, in the Zoom chat, can you paste the doc so people can follow along in the doc? Thanks.
Just figure out where the chat is here.
Go down to chat.
And there's a button you push.
And click that button, and then you can just paste it right in, send to everyone.
New chat.
At the bottom on the right-hand side between record and screen share.
Yeah, it's just, that's not what my screen looks like right now for some reason.
Oh, because you're sharing.
But we can see his screen. So yeah, like go click chats like you just did.
I'm gonna do
Yeah. This is more confusing than I thought it would be. Recent chat.
Okay. Alex, I just sent it out. So did James. Okay, great.
More, okay. I got it now. All right. So Ben, maybe you want to tell folks a little bit about what the work in libprocess has been recently?
Sure.
Okay.
So we have we've embarked on basically message passing performance optimizations as just some of the low-hanging fruit that we wanted to do before we did much else. Just because a lot of the subsystem is built on actors and passing messages between them, we figured that anything that we did from an optimization perspective there would just help all future optimizations as well. So let me paste in the ticket just so folks can see the ticket that we've been tracking all this work on. So it's Mesos 7798, and I'll paste that into the Zoom. Okay, there you go. So I just pasted it in there. And we'll put it in the doc too. So many places.
Yeah, I'm taking notes in the doc. So.
Okay, great. So, and then let me just kind of walk through so far. So basically, that code has been broken up into, I guess, 3 different phases. Was one way to talk about them. So, so before I say anything more to that, the benchmark that we used, which has been committed, is basically a new benchmark called the throughput performance benchmark, and it's based off of the benchmark that Akka had used in their for their actor implementation. And if you actually go look at the commit for that, there's some links to the Akka stuff as well if you wanted to follow along and see what that benchmark's doing. So then, if you're looking at the Mesos 7798, which is improve the process message passing performance, it's basically been broken up into three different phases. The first phase was a combination of things, mostly around removing locks in all the fast paths of the code. So some things we did where we didn't have to really introduce any new paths of code, and some things we did where we introduced completely new paths of code because we want this to be, I guess, I don't know if I want to call it alpha, but I want people to have to explicitly opt into it right now while we can make sure that there's no bugs or other issues that we run into. So an example of something that is not opt-in but everybody got was things like double-checked locking for working with the filter, which is something that should only be turned on at testing anyway, and during production there should never be a lock that should ever get acquired because the filter should always effectively be null. So that yields really large performance improvements just doing stuff like that. But some of the other ones that we did were things like introduce a lock-free run queue. And that's an example of something that needs to be explicitly triggered at compile time. So when you configure, you have to use -- enable -lock -free -run -q to Mesos when you actually build that to actually get the lock-free run queue. Okay, so that's kind of phase 1. Then phase 2 was basically introducing also a lock-free event queue. So not only having a lock-free run queue, but also a lock-free event queue so that there's no locks being acquired when actors are adding events into each of the other actors' mailboxes. Also one that you need to configure, so it's -- enable, I forget exactly what it is, enable lock-free event queue, I think is what it is. And then finally, the sort of third phase was a collection of other optimizations that we especially noticed were important on Linux. So probably the biggest one there is just the kernel, just using a semaphore, a bare set semaphore on Linux. We didn't really get great performance. So we kind of built a fixed size, last in, first out semaphore that yields tremendously better performance. And related to that last phase, I actually attached in Mesos 7798, I attached all of the, not all, but I attached a bunch of flame graphs that's capturing the performance wins that you see when you're using some of these last phases of optimizations. So both not using the LIFO semaphore as well as using the LIFO semaphore. And then also, all the same flame graphs are included where we have double the load. So we basically just increase the number of workers, number of actors by 2x. So anyways, so that's a pretty detailed account of some of the first stuff we've been trying to do in the process. And there's a lot more that we want to do. This was just on message passing. So probably the second phase past message passing will be the next phase will be also around the HTTP path. So not just message passing, but also the HTTP path within the process. So we'll create some benchmarks there and work on optimizing that. So that's also definitely in the queue. Now, all that stuff is in lib process. So as Ben said earlier, we also want to capture things outside lib process and Mesos. And as Ben said, we want to brainstorm where people feel like we should be spending most of the time and energy. But that's the lib process bit. So first, let me answer questions. So it looks like James had a good question. How hard would it be to make the lock-free run queue a runtime setting? Which one, for events or for the run queue, or both?
I guess either or both. Just thinking about how people would, take these and test it with their environments, making it makes it a lot easier for people to experiment and generate benchmarks than having to do builds through some kind of CI pipeline.
Yeah. So so the main thing that I didn't want to do was make the run queue be a virtual class. Like I didn't want to add the vtable overhead to the specific stuff I was optimizing. I wanted to let the compiler be able to actually inline and optimize the calls in through the run queue. So so that's one path. The other path to try to make it work as a runtime setting where it's still optimized, it's just messier, where it's not a polymorphic class. So if that's something that's interesting, I'd be happy we could take a look and actually make it happen. But it was just a performance reason. So
yeah, I guess Ben, to clarify, like the long-term plan is to have lock-free be the default and potentially eliminate the non-lock-free approach. Okay.
Definitely, yeah. Yeah, and then Alex R, you asked that as a follow-up question. Like, I mean, I'd love to do it sooner rather than later, but I just want to get some people to be running this in their test clusters and feel really, really confident and comfortable with it.
Do people know that there is such an option?
No. We literally shipped this code. We shipped the first phase like 6 days ago.
And phase 2 is not committed.
Yeah. Phase 2 hasn't been committed yet. Ben M's reviewed most of it. Phase 3 just went out for review this week. So we'll definitely, I think actually this would be a good opportunity for a blog post as well. We can write a blog post and we can talk about some of the optimizations we're doing in general, but no one knows about it. We still need to write better documentation for it. There's lots of stuff that needs to happen there. This is just an opportunity for us in this performance working group to already be looking at some of this stuff. And by the way, a couple of things I'll mention as well is if you are playing around with some of this stuff, like if you're trying to run the benchmark right now that I committed, I don't even think you can run that benchmark on your laptop. I think it'll take too long. I think it takes like 3 minutes or 4 minutes. I've never even waited for it to finish without the optimizations turned on. But when you start to turn on the optimizations, you still won't see the benchmark finish because you really need all these optimizations. Like if anywhere in the fast path there's blocking on a lock, it's like it doesn't matter. Like the performance is just abysmal. So you have to enable all of the lock-free event queue and the the lock-free run queue to actually run the benchmark. And then the benchmark will pass in like 2 seconds, 3 seconds, 5 seconds, depending on your computer. But you really have to enable all those things. So that's another thing to point out. Like if you are thinking about trying some of this stuff out, you should try them all, because you won't see really wins from just one of them.
Hey Ben, I'm looking at the perf2x no LIFO SVG. Can you help me figure out where in the flame graph you're seeing the bad performance of the semaphore? I don't see it in any of the stacks. Maybe I'm looking in the wrong spot.
Yeah. So it's in the perf2x no LIFO. You don't see it as much. If you look at the far left, if you downloaded that LIFO and you looked at it, the far left, right next to start thread, you'll see a sem weight, which is 1.34%. And then just next to that, if you go over again, you'll see another sem weight, which is 0.112%. And then if you go to the far right of the start thread, not far right, but just to the right once, you'll see a system call fast path, and just below that is the sem post. And then just to the right of that is a sem weight. So, you know, all these things. So what I noticed in my tests is that the semaphore performance on Linux was okay if you had enough actors and enough work that you were doing, and it was not as good. You know, if you look at perf just no LIFO, so not 2x, but just perf no LIFO, you see like we spend a tremendous amount of time in sem post and sem weight. You know, we spend 12.52% in perf no LIFO of just sem post, and we spend 4% in one sem weight and 6.73% in another sem weight. So
so is that missing part of the stack on the flame graph then? Because
you
shouldn't be calling sem post directly from benchmarks. You should coming through the
that's right.
The process path.
So what I believe is happening, I'm not 100% sure about this, but what I believe is happening, James, is that this is now in the kernel, and perf is capturing basically the kernel stack, and from within the kernel, it doesn't actually know where it's going to be returning to in benchmarks. And so this is like, so I'm not 100% sure about this, but I think basically the stack that it captures here is like, well, I can't figure out the rest of my stack. I just know it's in benchmarks, and this is the amount of the stack that I can figure
it's not stitching the user and kernel stacks together properly.
That's what I think. Yeah. So I'm not 100% sure, but that's my guess. So anyway, like it could be that there's something we can do about that, but so the two big implementation differences that I noticed in these semaphores on Linux versus the semaphores on Mac, because I didn't experience this on Mac at all on when I ran this on OS 10. The biggest implementation difference is the semaphore on Linux requires a guy that just got woken up, a thread that just got woken up, to try to repost. So when you do a post, if you can't post, you sleep, and then when you get woken up, you try to post again. Whereas on Mac, that doesn't happen. So the guy that gets woken up effectively already has done the post. In other words, the guy that's doing, sorry, when I was saying post, I meant wait in all those cases. The guy that's waiting, when they wake up, they can just keep executing. They don't have to keep trying to decrement the semaphore to go from there. So anyway, that's the only implementation difference. And I've got a couple of notes in the doc for how that could potentially cause a lot of threads to be getting woke up, not having anything to do, shutting down, a thread coming in, trying to post. So anyway, I think we can take that one offline if folks want to chat with me about specifically their thoughts around the performance from that perspective. I would love to have that conversation, but that's why for right now we introduced this LIFO semaphore. Sorry, yeah, well, I say LIFO semaphore, a LIFO queue for a semaphore basically, and it's not even strict LIFO. Okay, any other questions before we move on?
Yes. Yes, I've been trying to execute the benchmarks, Dario, by the way, um, on macOS, and I've been getting some recursive mutex errors.
Okay. Why don't you, Dario? Let's talk about that offline. Why don't we grab some time and we can look and see what you're getting.
Okay, sounds good.
Yeah.
And also, could you add links to the other patches maybe somewhere?
Yeah. I since I just posted them, I haven't had a chance to add them all to what Ben's looking at right now, Mesos 7798. I'll add all of them now and then you'll have them all.
Awesome, thanks.
So that was the first phase. Now I do want to point out that I know that Dimitri and folks have been doing other lib process optimizations, such as the stuff around not copying things, using R value references and all that stuff. So there's other lib process stuff we're going to do as well. There's a ton of that stuff that's also going to have huge performance implications. The big focus areas within the guts of lib process for us was message passing and HTTP and the HTTP stuff. So just wanted to lay that out again. Okay.
Okay, so let's talk about the work we're doing for faster master failovers. I don't know if Dimitri, you want to talk about some of your patches?
Yeah, sure.
Okay.
So it's captured in Jira 7713.
Okay.
So the basic idea is that when profiling master failover, I found that there are lots of copies of task statuses and all that stuff is done. So basically what we have with protobuf now is that it doesn't support move construction, but we do they are working on this now, and probably in the future it will be supporting that. So, but another thing in re-registration is a vector of I don't remember what, and it does support move construction. So every time we defer on to pass the message further, this vector is copied 7 or something times. So the idea was to just use move construction and help with that. I posted a spreadsheet which captures the run on our scale test cluster. That's basically dedicated masters with a bunch of agents running concurrently, on several hosts. Basically, we use Mesos to start Mesos agents. In regular conditions, this completes in about 1.5 minutes. But after this patch is applied, it runs for just about 1 minute. That cannot be solely attributed to the patches, because improving performance of registration in this place, it avoids duplicate requests for a registration, and that's part of it. It's because of faster registration, a part of it because of avoiding duplicate requests. So I have actually 2 sets of patches. The first one is 60003, and the second one is 60474. So the first part just improves number of copies made in dispatches, and the second one, it's improvement for incoming messages. it's currently marked work in progress in review board, just because we need to discuss how to make this work with protobuf arenas. That's not really clear, because when we convert something to vector, and if objects in this vector are coming from protobuf, then things become complicated. Like if they are on arena, then vector should be also using arena locator and so on. But in general, like this improves performance of converting repeated field pointer to vector. So yeah, that's all about it.
Okay. What was the second review chain number?
Hold on a second. It's 60474.
Okay.
And then Dimitri, I added on the Jira ticket. I made Michael Park the shepherd. So you're working with him on these, right?
Well, actually, there has been no activity for this for quite a while. So I was on vacation actually, and I just came back this week.
Right. But so have you chatted with Michael about it, with MPark about it, or have you not had a chat?
Yeah. He wanted to do some patches, like improving some things, but the problem was that this requires C++ 14.
Mm-hmm.
And so we decided to postpone it. Let me find the ticket for this, where the discussion was. No, let's continue. I'll post it to the chat.
Great. Okay. Ben?
Okay. Yeah, I think I had chatted with Dimitri as well about the protobuf move support, and we had found that it looks like they're planning to add it in the next release, so we might want to follow along. I can't remember what the issue number is for that on GitHub, but they did finally say they're going to do it, which is great. I don't know if I should try to find that right now, but I'll find it later and maybe add it to the notes. Hopefully they do that, because I think we can simplify some of the way we do the protobuf input path stuff, just to avoid like pointer lifetime ownership issues. But yeah, let's see if they really follow through on the move support or not.
Yeah.
Okay.
So I guess one question I have for that one, do you feel like do you feel like you have, Dimitri, do you feel like you've got a pretty good benchmark for that?
Well, unfortunately, there is no benchmark for this, because I was just running this on our scale test cluster and then just parsing the log and taking time from that.
Okay, yeah, I'd wonder if we could try and think about like a benchmark that that we could run so that we can ultimately optimize these paths through dispatch and defer.
Yeah, just one thing related to metrics, like when we first encountered this problem, like we were completely blind because metrics were not working at all. I mean, like it's currently HTTP request, which like it itself has several dispatches inside, like 5 or so, and the queue sizes were like thousands, hundreds of thousands messages. And basically running this metrics request required several minutes. And well, just like what we saw, it was just our metrics disappeared for some time, and then master is up and everything is over.
So you're saying because the metrics process is itself an actor, you couldn't get, and you had enough other work that was going on across the machine?
No. It's two-part thing. The first one is that it's HTTP request, and HTTP request to the master process.
Yeah.
So it has several dispatches inside, and every time when we dispatch to master, it lands in the end of queue, and the queue is huge. And another one is that just to acquire the metric, we need, for some of them at least, we need to do a dispatch to master, like counting the number of messages. It's a dispatch to master. Yeah, and that was the problem.
Okay, so we chatted briefly about this with last week with some folks, and Dario had a good suggestion, which was to introduce the concept of like priority messages that we could put and process before the other messages. So this feels like one potential use case for that. I'm going to try to capture that in notes.
Yeah.
Specifically around this, I don't know that we need that in many cases, because a lot of the defers that we end up doing on the metrics path could be implemented as counters. So Ben Mullerin landed a patch a little while ago that lets you implement a gauge metric using a simple standard function instead of a defer. So another approach is we can implement a gauge that's backed by a counter instead of a gauge that's backed by a defer. And sort of, if we do enough of those, then it should improve the metrics fetch time.
Yeah, I think we can talk about metrics in the bullet point you added here.
Okay, great.
There's a significant discussion there we probably want to have.
Okay.
Okay. So we got just over 20 minutes left. Just trying to think about the ordering of these. We can definitely discuss performance-related pain points, but I'm curious if we should try to fill out a planning table, or if we should try to talk about, metric sampling, benchmarking, build performance. If we do that, I don't think we'll get to fill out a planning table and kind of figure out what people can work on today. Anyone have thoughts on?
I think it'd be really good to hear from everyone what they believe are the biggest pain points, so that we can prioritize, which ones we focus on next.
Okay. All right. Yeah, let's do that then. Clearly, I'm going to just add the first one, which is master failover performance, which we're working on. A number of people are working on. Are there other areas that people want to call out?
Yeah, I mean, I believe that the general HTTP path could be significantly faster, and it feels like it's lower hanging fruit.
Yeah.
How about the JE malloc thing?
What's that?
The changing the system malloc library, but I probably don't have time now for that.
Just data point there, we always run our masters and agents under JE malloc. We just do it as a configuration option in our startup script.
Is there a way to move the project to have that be what everyone's getting?
Yeah, you could build it in. it's a little,
I've seen that in other projects. Like I think that's what Rust is doing right now.
it's a little weird, and you have you'll run into J&I problems. So originally I had a patch in our build system which did that. What happens though is you run into J&I problems because the J&I library is using JEmalloc, and then you end up, I think we ended up with a problem because the Java runtime environment was using systemmalloc, but the Mesos module
Yeah,
was using
I think I actually read about that exact problem when I was looking into how Rust was doing it.
So integrating it into the build system would need to solve that somehow, I guess. But for us, we just LD preload it. There's a little wrapper script that comes with CentOS that does it.
Well, I think we could at least make it the default if you build with Java disabled.
Okay. Any other topics people want to?
Yeah, I think there are a couple of low-hanging fruit in the master process. So just moving some stuff that is unnecessarily done in the master process out to just unblock the master a bit. Like, for example, all the HTTP API requests, all the messages in the body are being parsed in the master process, which I think is completely unnecessary.
Okay,
Hello.
we can hear you.
Okay. So adding to that, I think I was thinking about something additionally, which is to handle history related data from like the runtime data in the master and separately, which could potentially move archive things, which is just for WebUI, to another process. I mean actor, which I think could block the master actor less.
Yeah, so I guess some of these things I was hoping to maybe talk about in like when we're planning, when we're doing kind of like a planning table of like what we might work on. Unless you know that this is like a definite performance. Like I was thinking more for performance related pain points like, oh, our throughput in the API is bad, or the master takes a really long time to fail over, or the agent takes a really long time to recover from the state on the disk, or things like that, like high level kind of user experience pain points, more so than like,
exactly.
oh, we should work on, you know.
True. I was just adding to Dario's point. So,
Okay.
so I guess in terms of pain points, I guess the main ones. I mean, everybody probably have already mentioned most of them, like metrics and WebUI, slowness, and failover performance. And in terms of throughput, HTTP API throughput, I think Dario probably has more data on it. But I think the general feeling is that it could probably be improved, the speed. Is that right, Dario?
Yeah, so very early on when we started working with the HTTP API, I talked to Anand a lot, and he said that he had a couple of ideas on how to improve performance in the HTTP API, but he did not have any cycles to work on it. So it would be great if Anand is not here right now, right? No.
Yeah, I pinged him, and he unfortunately had a doctor's appointment this morning, so he couldn't come today. But he'll be the next one.
But yeah, would be great if we could make that a priority and give Anand a couple of cycles to work on that. Since he already has lots of ideas how to improve performance there.
Yeah. I definitely had talked to Anand a lot. So I think I know all those ideas he has, but yeah, we can, some of them are in the process itself. Some of them are up in how we write code up in Mesos land, but yeah, there's definitely a lot of stuff we can do there to make it faster. And I think if I recall correctly, the throughput is lower than the old API, right?
That's correct.
Okay.
I think you also didn't mention slow state JSON, Ben.
You're going to mention slow state. What do you want to say about this? Like it's
Still slow.
Slow.
It's slow, especially for bigger clusters. It takes a lot of time to generate it.
So is it that you just said it takes a lot of time to generate it?
I'm saying from the user perspective,
okay.
If you request state, then you might not get it for seconds.
Yeah, and I think the other problem here is that it not only takes a long time to be generated, but also blocks the master for the whole time.
Yeah.
Right. So actually, I was just querying our web UI. So probably this is going to affect. So the end result is it's affecting the speed of the responsiveness of the web UI, right? So not just the state.json itself, because we probably want to move off from that endpoint.
Okay.
But I was just looking at my Chrome performance trace of my web UI. So for one of our clusters, so when you hit the endpoint on state.json, the waiting time is actually 9 seconds, and the download time is 4.5 seconds. So actually spend twice as long waiting than downloading. So just something that I happen to have just tried.
So I was waiting for someone to mention web UI, so I'm glad you did. That's one thing that I think, the user experience is pretty bad for large clusters, or even clusters that aren't that large but have a lot of state. So I'm going to add that. Anything else?
Yeah, well, that's pretty good coverage.
Okay. Ben, what do you think? Should we use the rest of the time to try to, I think we should maybe figure out where people can actually spend their time helping with this effort while we're together now. Okay. So the way we'll kind of punt these other 3 topics for the next time. What I was hoping to do is, fill out this kind of table. We can just do it very roughly right now, but I'll clean it up later. I noticed that in the containerization working group, they have a nice table that kind of shows this stuff. So I'll make it kind of look like that. But for now, I just kind of wanted to get a sense of what are all the things that people think we should do, and who can actually help with which things. So I'll get this started so people kind of know what this should look like. So, and maybe people can write in the doc instead of just directly write in the doc if it's a bit faster. So I'll write, lib process, lock free, event queue, nh. We got the and process HTTP path, benchmarking, and process HTTP path, optimizations. Um, So this is kind of what I want it to look like. Just, you know, what the thing is and who's going to write patches and who's going to maybe help review. So, I mean, feel free to just add stuff or just call things out and we can write them down.
Do you want to move a few items from the section above to this table? Because you were saying these were specific ideas.
Yeah, I mean, especially if people want to work on them, yeah.
So for the lib process, sorry, go ahead, Ben.
No, go ahead.
For the lib process HTTP path stuff, I'd love it if somebody wanted to help put a benchmark together for that. You know, as part of some other work that we're doing for some of the networking work around domain sockets, we've already got some stuff in the works for optimizing the HTTP path. But we don't have a benchmark in it, and you know, especially folks that have a pretty good understanding of what their benchmark, what their HTTP traffic looks like. It'd be great to help get a benchmark in place for that. As in, like, what's the typical size of the protobufs, the number of protobufs, the frequency they're showing up at, yada yada. It would be great to sort of have that as a good benchmark to drive the optimizations we want to do.
Yeah, I think we should be able to get some data on that.
That would be amazing, Dario. That would be fantastic. What's the, Dimitri, what's the input path performance stuff again?
I wrote that down. It's just the having support for swapping or moving protobufs.
Oh, got it. Yeah.
And if they're const, you can use arenas. So kind of figuring out those two things. Yeah.
That's great. I'd be very happy to shepherd Dimitri on that. The big questions I have for that as well, Dimitri, is whether or not we can introduce some other things. How does shared pointer play with arenas? Anyway, we could take that conversation off topic, but I'd be curious how that one plays as well.
So we've been testing master failover a lot in the real cluster. So I think I'll probably write a benchmark for that, so it's easier to test.
Awesome.
Oh, okay. I can write that myself.
That's great.
Can we also make sure that each ticket that we work on related to performance has a performance label in it? This will help us to track those tickets.
Yeah, we'll do that. Okay, great. Ian, you're going to work on a master failover benchmark?
Yeah.
Great.
So I wonder whether that's too specific.
No, not at all.
But yeah, I think because this is one of the like very important cases, might as well.
Yeah. Okay. So it sounds like, based on just what people have put in here, probably no one wants to really work on the web UI related performance stuff right now. And,
so I wonder. So in a containerization working group, we put things in this table, even with no volunteers to sign up for them.
Yeah. Okay.
Yeah.
Well, we can definitely still do that. I just was curious to see if someone would volunteer.
Something related, but not strictly performance, but so we have a patch for the course support or prevent cross-site scripting vulnerability support for the web UI, which would remove JSON-P. I think that would enable further work on web UI to break apart.
Okay. All right. I mean, for next time, I'll have like a table filled out where we can see. I mean, maybe we can get more fine grained with it as well to see where people can help. For now, I think we've kind of got enough things going on. Maybe Ian, you're done with your registry patch that you had sent out. But we're still working through the lib process optimizations. And Dimitri still has his patches that need to get through. So there's enough going on right now. I think that we're good. But by the next time, hopefully we can continue making progress on some of these other things too. I don't think we have time to talk about any of these other topics this time. The metrics, the benchmarking, and the build performance. So we'll talk about them next time.
Yeah, sounds great. It's always good to have more topics.
Yeah, and feel free to add agenda items throughout. You know, if they come to mind, just feel free to put them in the agenda, and we'll talk about them next time.
Awesome.
So I'll send this out to the list, and I'll figure out the recording, where to get that, and I'll make sure that's available as well.
Sweet.
All right.
Cool.
Thanks, everybody.
Yeah. Thanks for joining, everyone.
Thanks, everybody.
See you guys.
See you guys.
See ya.